All right. It gives us a function, x squared minus 4, you should notice that's a difference of squares right away, over the trinomial x squared plus 5x plus 6. Select 3 true statements. At least they tell you there's going to be 3 that are true. Well, it's given us these choices of domain. Then it's talking about a point of discontinuity and then a 0. So obviously we're going to pick one of these. What's the domain? That's the hardest question that's here. The point of discontinuity, where can you not plug x in? X is going to mess up somewhere. Okay, so we have to have a point of discontinuity. Now, here's the thing. If we look at this, we could go to Desmos and graph, and we're going to look at that in a second, but this, we've got to sort of visualize too what's going on here. I notice this is a difference of squares, x plus 2 times x minus 2. The bottom, what multiplies together to give me 6, yet adds to give me a 5. Well, that's x plus 2, x plus 3. And notice what's going to happen is these are going to cross out. Now, when that crosses out, you cannot let x. It cannot be negative 2. We don't notice it. You know, if you simplify that and say, oh, this is just the graph of x minus 2 over x plus 3, which is what it's going to graph us. That's exactly what it's going to graph us. But x can't be a negative 2. That's going to be, there's going to be that discontinuity right there. So I know this is going to happen. It says there's a point of discontinuity at x is negative 3. There's not going to be a point of discontinuity. There's going to be a what? There's going to be an asymptote there. That's what's going to happen. Now, the other part here, we'll come back to the domain. There's a 0. Where's there going to be a 0? Well, this is sort of easy. They're just saying, hey, where is this set equal to 0? So where would this be set equal to 0? Now, you could simply plug in the number and see where it's going to come up to be 0. But we can look here in the bottom. What is going to create a problem? Well, it's going to create a problem when x is negative 2. We can't let x be negative 2. We already said that. So there's not going to be a 0 at negative 2. The 0 is going to occur at where? 2, 0. So if we just plug in, we would get 2 squared. Because again, x can't be negative 2. So we can't even use x to be negative 2. That's why I know that it's going to be a positive 2. If you plug in 2 squared right here, 2 squared minus 4, you get a 0 on top. The bottom is going to create whatever number it gives you, which is 4 plus 10 plus, doesn't matter. It gives you 16, but 0 divided by 16, oh, 0. So there's that answer. So we have 2 out of the 3. The next thing is the domain. So the domain, we know that basically everybody's working. X can't be a negative 2. Okay, there's going to be that discontinuity at negative 2. But and there's also, you can't have, there's an asymptote here at negative 3. So it appears we've got to mention that it's going to end up being this right here. So we're going to be having an x value from negative infinity to negative 3. It's not going to hit negative 3. That's why we don't have a bracket. We have a parenthesis. It's in union from negative 3 to negative 2. It's going to end up having values. At negative 2, though, there's that discontinuity, so it won't include it. And then it'll pick back up from negative 2 to infinity. Now, if we look at it, let's look at the picture I have. Here's a screencastify of it. You can see if I'm on this part right here, when x becomes negative 2, look what happens. Slowly, past it, negative 2. Do you see that? Undefined. So it's discontinuous there. But at negative 3, so it basically from negative infinity to negative 3, and I can show you here that if I come back to what I had graphed, and I can go ahead and graph, need to move that up, x equaling negative 3, so we'll do x equals negative 3, so that you can see, oh, it doesn't touch that. So from negative infinity to negative 3, it has a domain. From negative 3 to 2, you can see right here when it's, get on the blue line, when it's negative 2.5, it has values. It has values all the way to right up to negative 3. It doesn't at negative 2, and then from negative 2 to the right, it does forever. So that's why we can see there's where the domain is. difficult problem there. You got to sort of look at it. You don't want to jump immediately at graphing it, or you might get a little lost there. But think it through. Notice, hey, if I can factor and he can factor and some things can cross out, I need to think it through.